Today we're going to go over some modeling situations with differential equations. We'll start with a reminder of some vocabulary. F is in a direct or proportional relationship with A. In the next example, T is in an indirect or indirectly or inversely proportional to G. And in the last example, M is in an inverse cube relationship with F. Let's do an example. A puppy is going to gain weight, represented by W, at a rate that is approximately inversely proportional to its age, which will be represented by T. All right, gaining weight at a rate means that it is going to be dW dt. And so when we see the upcoming possibilities, we're first going to check, and every single one of them is going to start with dW dt. So that'll be good, but it also means we can't throw any of them out for that reason. It's inversely proportional, so we are looking for not a product but a quotient, and it's inversely proportional to T, which means we're looking for A. Example: a habitat of hamsters can support M total hammies at most. We're going to pay attention very much to the way this is written. The population grows proportionally, so it's going to be dP dt, and it's growing proportionally, so these things are going to be in the numerator. The product of P and the difference between M and P, difference meaning subtraction. So when we write this down, the population is dP dt, and it's going to equal, we always use K as some constant of proportionality, and then it'll be P times the difference between M and P. Let's verify a solution to a differential equation. And we want to know if this is a solution to the a differential equation. So we're going to take the derivative of the potential solution, and we're going to set it equal to the original derivative that we have written down and see if they are equal to each other. Instead of y, when we set them equal, we're going to replace y with what it equals in terms of x, and we'll see that for that one, it does not equal. In this second example, we're just using some alternate notation, so G prime. So we'll take the derivative of the potential solution, and we're going to set it equal to the original. And instead of G of x, in other words, our y or our output, we're going to replace that with what it equals in terms of x, so that we can do a direct comparison. You can slow down and watch my work to make sure that you understand step to step. We have taken derivatives like this before, so you might need to slow down and look it over to make sure you didn't make a mistake.